Alright guys, welcome back. Today we'll cover the basics of the coagulation cascade. This stuff can get pretty complicated here, but that is not the intent of this video. Today I really just want to give you a basic overview, give you a foundation to hopefully help you out in your studies here. So we'll look at this little diagram, kind of look at it more individually, and then we will scroll down here and see a little bit how they work together, hopefully help you out there. Alright, we'll start though here with the intrinsic pathway. So you have intrinsic and extrinsic, and they will eventually merge to form a common pathway, and that's how you'll end up eventually forming your clot. But in order to initiate these pathways, whether it's intrinsic or extrinsic, they have to be activated by something. So with intrinsic, this is going to be contact activation is how you'll initiate the intrinsic pathway. And what contact activation is, this can be things like endothelial damage, infection, or it's in the laboratory, they can do it with negatively charged glass beads. So really anything that causes surface damage can initiate the intrinsic pathway. As far as the clotting factors for the intrinsic pathway, there's 4 main clotting factors to memorize. So we have factor 12, 11, 9, and 8. So write those here. Factor 12, 11, factor 9, and factor 8. And how I memorize which clotting factor is the intrinsic pathway, I kind of think of it as a countdown, right? So it's 12, 11, you skip 10, then it's 9, 8. So I think of this saying, it's countdown, in, and then you start, right? So in for intrinsic. So countdown in, 12, 11, skip 10, 9, 8. That's how I memorize what clotting factors are in the intrinsic pathway. And then if we move over here to the extrinsic pathway, so this one could be initiated by things like trauma and inflammation. And as far as the clotting factors on the extrinsic pathway, this one's a little bit more simple. So this one, really only 2 you need to know is to be factor 3 and factor 7. So I'll write those here. Factor 3 and factor 7. And it is important to know that factor 3 is also known as tissue factor. And that is actually probably most common. That's probably what you'll see it be called is you'll see it called tissue factor. As far as for memorizing which clotting factors are in the extrinsic pathway, so this one, so we have the X here in extrinsic, so we know that X is 10, and then we know the clotting factors we have are 3 and 7, and if you add those up, you also get 10. So that's how I memorize which clotting factors are in the extrinsic pathway. Now, another important thing that's really commonly tested is lab values for each pathway. So for the intrinsic pathway here, this is going to be PTT, and then for the extrinsic, this would be PT, and then we have memory tricks for these as well. So for intrinsic, we'll go back over here. The saying to memorize this is you play table tennis inside. So PTT, and then N for intrinsic. So PTT for intrinsic, play table tennis inside. And then for extrinsic, just PT, right? So here you just play tennis outside. So play tennis, that's PT, and then outside, I just associate that with extrinsic. Then if you move it on down the pathway here, so eventually these pathways will merge to a common pathway. And here, once again, there's 4 more clotting factors to know with the common pathway. This is going to be factor 10, 5, 2, and 1. So write those here. So factor 10, 5, 2, and 1. And factor 2, so this is prothrombin, which is eventually converted to thrombin. We'll talk about this a little more down below. And then factor 1, this is fibrinogen, which is eventually converted to fibrin. And fibrin is actually how you'll end up with the clot formation eventually. clot formation there. Thrombin is really important. Once again, we'll talk about that down a little below. But so this is how, so you can kind of see each pathway individually a little bit and see how they'll end up merging there. I don't really have a memory trick for memorizing the clotting factors of the common pathway. As far as like a little saying, how I kind of think of it is they kind of go in half, right? So 10, you half it, goes to 5, and then 2, you half that, it goes to 1. So that's just how I remember the clotting factors for the common pathway. Sorry, I don't have anything any better than that, but let's scroll down here and let's take a look. I like this diagram a little better. You can really see how they kind of end up working together. So start over here on the intrinsic pathway. So once again, I said this is activated with contact activation. So you have factor 12 here, and you see that becomes activated factor 12. So this little A here, this just means for all these, means activated. And then you can see how it's kind of a domino effect, right? So activated factor 12, that's going to activate factor 11. Factor 11 will activate factor 9. You can see factor 8 here. So this is actually a cofactor of factor 9. So that just means it's just helping the function of factor 9, right? So, and then you'll see activated factor 9 will eventually activate factor 10. And if we switch over here to the extrinsic pathway, so here's our tissue factor, also known as factor 3, like we discussed above. That's going to turn factor 7 into activated factor 7. And activated factor 7 will also activate factor 10. So once we get here in the green with factor 10, so we're now in the common pathway. So we go and move down here, we have activated factor 10, once again, another cofactor, which is factor 5 of factor 10, so helping to improve its function, right? And then we get down here, factor 10 is really important because this is what will convert prothrombin into thrombin. So thrombin does quite a few things, but for the purpose of this video, we're just gonna stick to this pathway. But this is the main procoagulant enzyme. So procoagulant meaning it's helping to clot, right? Like I said, it does many things as far as helping these other factors in the pathway, extrinsic and intrinsic. But the really important thing to know with thrombin is that it's going to convert fibrinogen into fibrin, and then this is how you ultimately end up getting your clot there with the fibrin. So that's a little bit more of a picture of how they work together. Both these diagrams kind of show similar thing, just a personal preference. Personally, I like this one a little bit better just to see everything. But if you learned anything, please like and subscribe to the channel. Any questions, please let me know down below in the comments, and I appreciate y'all for watching. Thank you.